So another question here, we have a thermistor rated at 5 k ohms at 0 degrees, so that's one set of data, and 200 ohms at 120 degrees. So just to make that clear, there's a K on this one, so that's 5,000 at 0 degrees. That means it's decreasing in temperature down to 200 ohms as it increases, decreasing in resistance as it increases in temperature. Now, assuming the resistance-temperature relationship is linear, what would the resistance of the thermistor be in a tropical fish tank at 40 degrees Celsius? So the actual context here is irrelevant to this question. We've been given two data points, 1 and 2, and we're told it's a linear trend. So we can just plot ourselves a little graph, and we can see that 5,000, if we have temperature here and resistance here, it doesn't really matter which way around you do this. If our temperature is at 0, then it's at a resistance of 5k, so if we call that 5k, or 5,000, and then at a temperature of 120 degrees, it's at, I should really have put that out here somewhere because it's non-zero. 120 degrees, it's at 200 ohms. And we just have a nice straight line, and we're trying to find for 40 degrees, which is somewhere in here, somewhere in the middle, and we're just trying to find the resistance at that. If you prefer, you can form an equation out of this where T equals negative something times R, and then you've got your equation that you can substitute 40 degrees into. So that's how you'd solve it. B. I'm not actually going to do the answer though. B, in this thermistor circuit, what would be the voltage at P become if the temperature dropped to 30 degrees Celsius? Okay, so, or if the temperature was raised to 40 degrees. So you're going to use your graph again. You're going to find 35 degrees and 45 degrees and what resistance it is. Once you know what resistance it is, then you can consider this purely as a voltage divider, where the voltage across P versus the voltage across the 10K will be according to the ratio of resistances. So the voltage of the 10K is of the same ratio to the voltage of P as the actual 10K is to the resistance when it's worked out according to these things from our graph. Okay, so that's how you solve that. It's actually not too tricky, but if you're not confident with your working out your voltages and resistances, if you're not confident with calculating voltages in a voltage divider circuit, then that's going to make the rest of it seem a lot harder than it really is. It makes it harder to break it down into manageable units that you can then deal with this one, then move on to this one, then move on to this one. That's what this question's like. So first unit would be looking at working out this graph kind of situation, which is what the first question A is trying to help you with. And the second is using that graph to find unknown values. And the third unit is using those unknown values in a voltage divider situation down here using ratios. So the other formula that might be useful is that the voltage you're looking for will be, voltage at P will be equal to the supply voltage times by the resistance at P divided by the total resistance, which is resistance at P plus the 10K. And that, yeah, we'll plug it in, it'll work perfectly.